Yeah. Those. Is that you? Yeah. Hey, all right. All right, so last time I didn't really give out anything, but anybody still need 11.1, 11.2 stuff, packet, little handout? Guys, the back side of this one, has a nice summary of all the methods, factoring, taking a square root, putting plus or minus, completing the square so then you can do this, and then the shortcut to this quadratic formula. There's examples back there how they work. I want to do something with completing a square. Because I got a few questions earlier in the lab. Let me see. We got you. Okay. So how do I figure out what goes here to complete the square? And the whole purpose, the reason we call it complete the square, is I want to figure out what do I add to both sides so that this side factors like x plus or minus something squared. Because then I can square root. Okay. So how do I figure that out? Yeah, the first step is cut 10 in half. Second step is to square that. Now, real quick, I showed you why that's true, but it's very easy as a student to forget why that's true. And then you do some of these, and then you go, why does this work? Or, all right, whatever, just do shit. Just a real quick little side note, just to remind you guys why those two steps do what they do. If I square x plus 7, what do I get? X squared. 7x and 7x. That's right. 49. If I would have put a 5 here, that would have been 5 and 5, right? Then it would have been 2 5s. If I would have put a -2 here, that would have been -2 and -2. There would have been 2 -2s. Whatever I put here, whatever's in here is represented in the middle. The middle is twice it. So the middle is 14x, which is twice what was in there. So that's why when I take half of 10, that very first step, it's related to figuring out what must be in here. Half of 10 is 5. That must mean there was a 5 there. And then this guy tells me what to put there in order for that to work. It feels a little backwards because the first step tells me what it's going to look like. And the second step tells me what to put there to make it look like that. But that's just because it's a backwards pattern that we saw. We start with the answer and we work it out and we see the patterns to figure out how to get these numbers. So this would be x plus 5 equals 32. Square root both sides, plus or minus. blah, blah, blah. I don't want to focus on that right now. So what about if it was x squared minus 7/15 x equals 2? Yeah, Jeff, go from 10 to negative 7/15. Thank you. You're such a nice guy. But again, the first step tells me what's going to go here. The second step tells me what to put there to make it work. Why? Because that's the pattern that we saw. That's the pattern that we saw to build this process on. So what is half of negative 7/15?
7/30.
Yeah, taking half of it, you just multiply by half. I haven't made a big deal of this because I don't think it's come up yet, but the word of, what does of mean in mathematics? Half of something, 80% of something. What does of mean? Multiply. It used to be just a standard thing. You come out of high school knowing there's 12 inches in a foot, and of meant freaking multiply. Nowadays, holy shit, I don't know what happened. You don't know what the hell of means. Depends on your definition of the word. A little old. So half of negative 7/15 is negative 7/30. What does that right there tell me?
49.
No. Before I do the second step, what does that by itself tell me? What's going to go in here? Now the second step tells me what to put here in order to make that actually factor that way. So what is negative 7/30 squared?
49 over 900.
900, yeah, babe. So then you got plus 49 hundredths, plus 49 hundredths. All right, so this is that little two-step process, just to figure out how this is going to factor, to figure out what goes there, and then you got the LCD, blah, 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 here. Square root both sides, plus or minus. All right, does that... So I've got to reinforce that connection between the shortcut process, why it works, and then what the hell to do with each of these. That's why this doesn't really bother me that much. And you guys are like, well, yeah, you know math. It probably doesn't bother you any of it. But even as a student, I wouldn't get bothered by this because the process does most of the heavy lifting with the fractions. The most I have to do is get LCD between those two. Okay, cool. I like it. Maybe. All right. I think we finished. We were talking about the discriminant stuff. Let's kind of go back and look at that before you get into new stuff. The discriminant. Discriminant, yeah. That'd be really horrible, Marvel movie. Discriminant, yeah. So what is the discriminant? Yeah, b squared minus 4ac. And in the quadratic formula, where does that sit? Under the square root sign. That's right. Under the square root signs. That is why I can look at that by itself. It is almost the most important piece in here. This is so evil. There is another door. It's like a test. It should be the first day. A test to see if you belong. Sorry, Sierra. It's happening to everybody. So, if b squared minus 4ac was negative, if that was less than 0, less than 0, yeah, because it's under the radical, that would make these complex, so there would be two complex answers. So if the inside of the radical is negative, I obviously get real part, imaginary part, I get complex answers. If it's positive, then I must get two real answers. It's way too real. And if it is 0, then the whole reason there's two answers goes away, right? Why is there always two answers almost? Plus or minus. And if it's 0, though, it just takes the plus or minus with it. It's gone. plus or minus 0 is just the thing. So then I get one real answer. Bam. So when they ask you, determine the number and type of solutions, all you have to do is look at b squared minus 4ac. Don't start to actually put the whole thing together. I don't want you to do that. Okay, cool. I like it. So for example, how many and what type of solutions does this have? So what's A?
-5.
What's B?
-3.
C. The biggest mistake I see with this and the quadratic is somebody's going to tell me this is negative 121. And then they even bring their calculator up and they say, well, Jeff, here, let me do it for you. I plugged negative 11 squared in the calculator and it told me it was negative 121. Yeah, it does. Calculator does tell you it's negative 120 because that's what that is. But that's not what I need for this. You guys see the difference? What am I squaring? B. What is B? Negative 11. I better square that number, not just part of the number. I don't just square the 11. That's not squaring B. It's squaring a part of B. That's not what this says. I'm not sure how I would say that. So negative 11 squared minus 4 times negative 5 times 3. So you get positive 121 plus, and then I almost would love it if somebody would just stop and go, it's 2 real answers. It's 121 plus, okay, screw it, it's going to be positive. Who gives a shit what this is? But let's see, 20 times 3, 60, and then you get 181 greater than 0, so you get 2 real answers. I like it. I like it. That's enough of that. Okay. Now, the very last thing we did yesterday, let's do a few more of those. Let me see if you guys really get this idea. If I have this situation, stay with me, guys. If I have this, and somebody tells me that one answer to it was negative 3i. This is kind of a weird thing, but not really. I kind of said something about this last time, but for one thing, how do I know that's not the whole answer? Let's see if somebody remembers. I'm pretty sure I said this. Maybe I didn't say this to you guys. You guys know how to tell how many answers a polynomial kind of equation is going to have? Have I told you this before? Like if I had here's a quick little side note. Side note. If I had an x cubed plus x squared minus 2x plus 7 equals 0, I know that there will be 3 answers. Maybe some of them are complex, maybe some of them are repeated, but there will be 3 answers because of a third degree. You guys with me a little bit? A little tiny bit? Now, in pre-calculus, if you are going to go to pre-calculus, you've got to get a lot deeper into this idea. A lot. So how many answers should there be to this then? 2. I like it. Now, where would negative 3i come from? What must that mean happened? Right, so here's this thing. What must have happened then in order for me to get an answer like this? This must have been less than 0. You with me? In fact, some of you guys might be able to figure out it must have been -9. But what does that mean then? That means that this is like 3i kind of stuff related to it. There's a plus or minus though. So if one answer is negative 3i, there's got to be another answer that is positive 3i. There has to be. So x equals 3a also works. So if one answer was x1 equals 2 minus I, then the other answer has to be 2 plus I, the conjugate. And this is what I said yesterday, but I said it once and kind of quickly, but they have to show up in complex conjugate pairs because of that. It's real number plus or minus imaginary number. Real number plus or minus imaginary number. That has to happen. You can't have a single complex number, that be it. I like it. Okay, now. Let's remember that last thing we talked about yesterday. If I know that x equals 3 and negative 5 are the answers, what must the equation have been? How do we figure out what the equation must have been? If 3 and negative 5 are answers, what must the equation have been? So let me do one straightforward. If the problem was this, right? Then what would the answers be? The answers would have been 3 and negative 3. So since there's a negative 5 answer, where would that have come from? X plus 5. If since there's a 3 answer, where would that have come from? Yeah. And then you can multiply this out to make it look a little more official looking, right? That's what the equation would have been that led to those. So let's do one that's a little more interesting. What if x was plus or minus 7i? Don't say anything out loud. Try to figure out where would that have come from. What would the equation have to have been? This feels a little weird, maybe. But there had to have been an x minus 7i and an x plus 7i. And how do I make that into what the equation was to begin with? I FOIL it out. So I get x squared plus 7ix minus 7ix. The middle cancels. And what's negative 7i times 7i?
49.
Negative 49 I squared. And what's I squared? So you end up with x squared plus 49 equals 0. And here, how would you solve that? You subtract 49, take square root, plus or minus. Square root of negative 49 is 7i, plus or minus 7i. There you go. So there will be several problems asking, giving you the answers and saying recreate the equation where that would have come from. All right, here comes the ultimate one. What if I had a third degree polynomial equation with x equal to, wow, Jeff. What if I had a third degree polynomial equation with x equal to 5 as the only answer? Now, since it's a third degree equation, how many answers must there be? 3. And then I'm saying x equals 5 is the only answer, but that must mean that it was repeated twice, right? It showed up once and then it was repeated. So, where would 5 have come from? Where would that answer have come from? X minus 5. Well, how many more do you have of those? 2 more. How do I know I have 3 of them? Because the problem said I had a third degree. I had to have 3 answers. If I really only have 1 answer, that means it showed up 3 times. That's what that means. And you can go, well, you weird-ass math people, that's 1 number. And I'm like, no, that's 3. They just all happen to be 5. That's 3 answers. They just all happen to be 5. And then you can multiply this out. Woo! Let me see if I can do it real fast. No, screw it. I could. You would eventually get that if you fold it all out. I think. Let me see, there's one thing I left out. 1, 3, 3, 1. Yeah, there you go. Freaky, freaky. Anyway, you guys could all foil it out. It's no big deal. $75, yeah. That's 15, yeah. Just in the off chance that somebody in the audience would actually be interested enough to look this up later, there's something called Pascal's triangle. Pascal in his grave is like, get all that work. She thinks it's stupid. It's unbelievably awesome. It looks so stupid, I know, it does. What's that? Now watch this, watch this. How did I make this?
Because you added this.
Yeah, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3.
Yeah. I know how it works. I just don't like it.
1, 4, 6, 4, 1. There's a lot of nifty other things about the diagonal, adding together, Fibonacci sequence, all that kind of stuff.
Oh, I don't know that.
All right. But stay with me for a second. I know I go off in tangents. I know I do. I have a shirt that I want to get that says I go off on tangents sometimes. Tangent is actually a mathematical function, so it actually has a stupid joke to it. But real quick, just because I put this down here, just suffer with me for a second. You guys are like, that's what we do every day. If I had x plus 1 cubed, that's related to this. Actually, look at this. What's x plus 1 squared? You guys take a minute. What's x plus 1 squared? Foil that out for me. Do it. X squared plus x plus x. What are the coefficients in this? 1, 2, 1. 1, 2, 1. So if I had x plus 1 cubed, that would be x cubed plus 3x squared plus 3x plus 1. 1, 3, 3, 1. 1, 3, 3, 1. Did they show you that part of it? Little Miss Texter over there? Did they show you that part of it?
Yes.
Okay. All right. Fine. If you're not impressed by impressive things, I don't know what to do. Okay, so coming back to what we got to worry about for this class. All right. One last one here. I'll do this together with you because this is the ultimate evil one. Second degree polynomial equation with one answer being 1 minus 2i. Now one part of this is just, can you tell me what the other answer must be? It's based on what we talked about earlier. What must the other answer be? 1 plus 2i. Now, when it was 5 and negative 3, that was x minus 5, x plus 3 equals 0, right? When it was 5, repeated 3 times, it was x minus 5, x minus 5, x minus 5. So what if it was 11? It would be x minus 11. What if it was w? X minus w. So what if it's 1 minus 2i? Where did that come from? Where did this come from? You can do it. If it was 7, you would say x minus 7. Right? That's where 7 would have come from. That's where that answer would have come from. So where would 1 minus 2i come from? X minus 1 minus 2i. So where would 1 plus 2i have come from? X minus 1 plus 2i. Now, follow that out. I'll give you a little hint. You should probably... distribute those negatives, right? Ooh. Oh. Like some of you guys are just going to be like, you try to make me do that shit. I'm just going to sit here and stare at it, all right? You're not doing anything for me. This is all shit for you. If you don't want to do it, it's fine with me. Whoa, yeah, full of press. Okay. So once you distribute, you get these, right? And now you got, okay, here we go. Oh shit, x squared minus x minus 2ix. All right, that x got its turn done, right? Now you let the negative 1 go through. Nothing amazing here, nothing magic. It's just you gotta have a little bit of stamina. Minus x plus 1 plus 2i. And then this gets a turn. Plus 2ix minus 2i minus 4i squared. Right? That's not hard. It's just, you gotta just do it. And now you gotta get my like terms together. X squared's got nobody. What about the x's? Minus x, minus x. Yeah, so that's minus 2x. What about the 2ix's? Or the ix's, right? There's an ix piece. Any more ix pieces? What do these do to each other? That's right. We already got those together. What about the I pieces? 2i minus 2i is... And then I have... so then I have a 1, and then what's I squared again?
4. Negative 1.
Negative 1, so this becomes plus 4. So this is x squared minus 2x plus 5 equals 0. Bam. I like it. Now, you guys take a second, Solve that for me. What's happening? Can't factor that. What happened? Oh, the sun came out. Right. See if there's any vampires. No. Yeah.
How would you compare negative 4i squared to 4?
Sorry, say it.
How would you get negative 4i squared to negative 4?
What's I squared? I squared is negative 1 times negative 4 is the plus 4. So any I squared term will become the opposite sign of what it was. Because I squared is negative 1. What method are you guys using to solve this? Can't factor. Foil, there's nothing in foil. Quadratic sounds like a good idea. So negative b plus or minus square root of b squared is 4. Minus 4 times 1 times 5, all over twice 1. Two plus or minus, what's 4 minus 20? 4 minus 20? Negative 16. Square root of negative 16 is? 4i. And then I just cut everybody in half. And of course, what was where did we start? That the answers are 1 minus 2i, 1 plus 2i. So of course we got that when we solved the damn thing, because that's where we started from, right? So starting from this, putting it in, and then doing all this mess is just creating this. And of course, so when I solve it, of course I'm going to get that back, because that's what created it. All right. Hopefully some of you guys knew that was going to happen. You knew the answer from the beginning. Okay, so here's this is all review, by the way, in a way. Here's the new stuff for today, and then we'll head out. Let me start off nice. Actually, look here. Let's just do the one we just did. It's kind of gross. What would you do to solve this? Factor. What do you always try first? Factor. Now, some of you guys are like, I don't know how to factor, so I don't try that first, Jeff. And I'm like, that's bad. Right, factoring is immensely important. You don't just go, thank God we got the quadratic, I could screw factoring now. You better believe on the test, I'm going to have a solve by factoring section just to make sure you remember how to do that shit. So how do you factor this? Now why'd you put an x there and there? That's kind of a silly question, but why is that an x and an x? Because it's x squared. Notice how the middle term will then have half of this guy, because what did we do to this guy? Cut him in frickin' half. Put him in both, right? So then the middle term is just going to pick up half of them and half of them. You with me? So that's a little weird to say it that way, but I don't care. So the answers here are 8, negative 2. Okay. Now, so that's old. That's old news. Now, what if I had this? I want you to notice something. Do you see that? The first problem, the power in the middle is how related to the power on the first guy? Half. And you see how that's important? Because what do we do with the first guy? We cut it in half. So is this in a form I can do that same thing to? Yes, because the middle power is half the first one. So I could have put a 10 and a 5. I could have put a 6 and a 3. I could have put anything where the first dude is twice the middle dude. And it would be able to be done. So how the shit do you do this? Well, hello. Yeah. guy in half? And of course, we already know the numbers that work, right? Don't we? Same numbers that work.
Yeah.
Coefficients aren't different. So it'll be minus 8 plus 2. But now we get a little problem to solve. How do you solve this guy? Add 8. Square root. How do you square root of 8? Yeah, 8 is 4 times 2. So some of you guys hopefully are starting to just know that the square root of 8 is 2 rad 2. There's a few of these that are real basic that should maybe stick in some of you guys' heads. So this is plus or minus 2 rad 2. What about this guy? Don't just stop there now, right? We know better now. We know how to do this. Square root, plus or minus. So x equals? Plus or minus? I? Rad 2. How many answers is that total? No. How many answers is that total? Which makes sense. I like that reaction. That's a good reaction. Some of you guys like, whatever, man. Circle the 4. That's a shit. So there's 4 answers because it was a 4th degree problem. Right? Yes. Now, let me give you a more general way to do this. Because it's not always going to be factorable, and that gets kind of disgusting. So let's do one that's not factorable, and I show you an alternate way to do this. It's something called U substitution. So what if I had this? What do you want to do, Jeff? Let's just keep it simple for that. Yeah, I agree with that, Jeff. Let's do x to the 4th minus 3x squared plus 7. So keep it simple, Jeff. Can you do this shit? Yeah. Yeah. Now watch. Here's what U substitution is. See how the form of it is the right form? Why is the form of it right? Why is it? Yeah, this is half of that. So that tells me it's what's called quadratic in form. That's the official name of it, quadratic in form. So the U sub thing is really useful when I don't want to look at this shit. I want to make it look more like what I'm used to. So what am I used to seeing in the middle? Not x squared. I'm used to seeing just x. So let's let a single letter be x squared. Because what is x squared? Tell me. What is x squared? Do you know what it is? No, I don't know what it is. So let me call it u. If u is x squared, if u be x squared, I love grammar, it goes out the window with u sub. If u is x squared, then what's u squared? Yeah, so how can I rewrite this problem now? Instead of x to 4, I can write u squared. Instead of x squared, I can write u. Now that looks, beyond my horrible writing, that looks more like what we're used to seeing, isn't it? The power of u sub is it takes something and it makes it look like what I'm used to seeing. Now the problem is, if you get answers for u, you're not done because the question has frickin' x's in it. So whoever asks a question, you're like, u is 7. I don't give a shit. I asked you what x is. So you got to make sure at the end, you figure out what the hell x is. So how would I figure out what u is first? What do I do here? Can I factor that? No. So what do I do? Quadratic formula. I could do completed square if you really love it. But how does quadratic formula get set up? Yeah, negative 3 is 3. Give or take. Yeah, negative 3 squared is 9, minus 4 times a times c, all over twice a. That's what u is. That's what u do be. So you're going to get 3 plus or minus, what's 9 minus 28?
19.
Negative 19? So u is 3 plus or minus I rad 19 over 2. So if you stop there and circle that, you're going to think you're insane. Like, ask about no u. So that's just the middleman. The u is just the middleman to make it easy for us to do. Now, what was u?
X squared.
Yes, u is x squared. And do you see how this now, oh, you're going to love this shit. That is now a little problem to solve, but it's almost, how do I solve that for x? What do I do to both sides?
Squared.
Yeah, and you don't worry. Does that look pretty?